All right, so we will do something called as functions today.
Mhm.
So functions are basically notations. It can be in the form of notations. It can be in the form of a function like f of x or g of x, or even a composite f of g of x. Okay, so f of x is a function of x, g of x is a function of x, and then f of g of x. So this is f is a function of g of x and g is a function of x. So this is called as a composite function.
Mhm.
Could be asked.
Yeah.
So suppose f of x is x squared plus 2. So what is f of 5? So you substitute value of x as 5
Yeah.
and solve the expression. And reverse also could be asked, which is g of y is given as 11, and you could be asked what is the variable. So the function is known, but the variable is not known. So obviously you can substitute for g of y is 11, and then 3y equals to 15, and y is equal to 5 in this case. Yes?
Yeah.
Okay. All right. Quant comparison. Fx is 2x and g of x is half x. Two different functions. And we are asking composites. So let's
Mhm.
try to understand what is A. A is f of g of 3. Firstly, what is g of 3?
3/2.
3 by 2. And what is f of 3 by 2?
3.
3. Fantastic. And what is B? G of f of 3. And what is f of 3? 6. So g of 6 is what?
3.
3. So both are equal. So here, the functions are simpler to solve.
Mhm.
And you're given the variable values also inside. So it becomes a simpler problem. More complicated varieties are those wherein you do not know the value of x, but is generalized, like f of g of x.
Yeah.
Yes. Okay. F of x is x minus 4 square, and g of x is x square minus 5. So f of 2, can I say, is 2 minus 4 square is minus 2 square, which is 4. And g of 2 is 4 minus 5, minus 1.
Yeah.
So the answer is 5, is it?
Yeah.
Easy one. Easy varieties,
Mhm.
both of these. Okay, let's do this. F of x is given. And we are asked what is greater. So no need to solve this actually. Answer is A. And why is that? Because if you substitute for 3, what do you get?
7.
So is answer A or is your answer B or is your answer C? It can't be D because the numbers are given, right? Variable value is given, so it can't be D. So one way is to just substitute, right? So f of 3
Yeah.
is what? 3 cube minus 9 into 3 plus 17. Can I say this cancels out? And you're left with 17. And f of minus 3 is what? Minus 3 cube minus 9 into minus 3 plus 17. Again, these two cancel out.
Yeah.
So both are equal.
Yeah.
Okay? Simple, right? Whenever the variable values are given, straight away just substitute. Nothing else to do.
Yeah.
Okay, next. F of x is x minus 1 by 4. And now somewhere w comes into the picture. So that, can I say that's like one of the realized values of x? One of the values of x is w. So what is the value of w? So again, we will directly substitute. So we get w plus 1 divided by f of w is w minus 1 by 4 equal to minus 2. So w plus 1 divided by w minus 1 equal to minus half. Can I write? Now you can solve it, or you can use plugging in. But this is an easy equation to solve, so might as well just solve it. So 2w plus 2 equal to 1 minus w. So 3w equal to minus 1. So w is minus 1 by 3.
Yeah.
Plugging in takes more time if it involves fractions. And that's where we will avoid plugging in. Whenever there are fractions, avoid plugging in. They will take more time for you to solve. It's better to just solve this equation, will be faster. So this is also an art to understand where to plug in and where to just let go and just solve it the way it should be, like an equation. So whenever we have easy values for the variable, like 0, 1, 2, 3, minus 1, minus 2, plugging in will work well. As soon as you get fractions, avoid plugging in.
Yeah.
Okay. Fantastic. Next question. Symbolic expressions. So these are non-mathematical symbols. So these are not functions, but these are symbols which could define an operation. Let's look at an example. So you have the square n equal to 5n, which means square equal to 5, basically. So which is greater, 1 or A or B? So how will we simplify A? 15 plus box of 3 will be what? 5 into 3? 30? A is 30. And can you try B?
It's also 30.
Yeah. 5 into 12 by 2. Okay, so both expressions are equal.
Yeah.
Okay. Next, all good?
Yeah.
Simple, right?
Mm-hmm. Yeah.
Quite harmless so far. Okay. Now what's this? This is like that card spade. J- This equal to j plus 3, which means you're incrementing this by 3, and this semicircle here of j is j square plus j by 2. Fantastic. So let's solve for a. So how will you do a?
You put 2, you put it's 2 plus 3, which is 5, and then you put the 5 into the second equation, so it's 5 squared plus 2 over 5, and that's 27 over 5.
Yeah, so can I say this acts like a composite function, right?
Yeah.
Yeah. So what's that? 5 so j plus 2 by j. So 5 plus 2 by 5. Okay. And what is this expression b?
Um, it's first you plug the 2 into the second equation, so it's 2 squared plus 2, which is 6 over 2, which is 3, and then you increment it by 3, so it's 6.
So is it 6?
Yeah.
Okay. So which is greater?
Um, B.
B. All right. Simple, right?
Yeah.
Just the knowledge of composites is enough. Okay. So this is 3 and dot is plus 7. So what is this? Dot 4, can I say, becomes 11?
Yeah.
And this of 11 becomes 33. Minus dot of 2 is 9. And 3 into 9 is 27.
Yeah.
Okay. Last one. This I'll leave it to you. And I've started timing you as well. Done? 3 minutes. Four and a half minutes.
I think I'm stuck. I
Where?
tried to do it, but I'm getting a really big number.
How do I see your solution?
Um, should I just explain it?
Can you click a photo and send it on WhatsApp?
Yeah.
Done? Have you sent the pic?
Yeah, I just sent it.
Okay, yeah. All right, now you can explain me what's going on.
So first I tried to put the 2n and the 2 into the first equation.
Hmm.
So 2 times 2n minus 2 squared. And then I got 16n squared minus 16n minus 4. And then I tried to solve for n by taking the second equation and putting the 5 and the n minus 1 into the second equation. And then trying to equate it to 5n squared plus 4n. And I got n equals to minus 9 and 1. And then I tried putting both of those into the first answer I had. So the 16n squared minus 16n minus 4. But one of the numbers was negative and one was like 500.
Okay, all right. So well tried. So, so the way I will do this is I need this expression, but I will touch this towards the end. I'll work with
Yeah.
this. I will work with this.
Mhm.
Okay. Once I know n, so clearly, can I say these all options are some numbers, right? Which means ultimately I should be able to get n. So no need
Yeah.
to touch this initially. we will work with 1 and 2.
Yeah.
Okay, now 1 is what? AB, right? So if I substitute A as 5 and B as n minus 1, what do I get? 5 plus 2n minus 2 whole square. So that's your 1, correct? Which
Yeah.
means it's 2n plus 3 whole square, correct? And I also have from 2, this 5 into n minus 1 is 5n square plus 4n, which means these two can be equated because the symbols are the same and the order is
Yeah.
also the same. And A and B I've substituted as 5 and n minus 1 respectively. So both can be equated. So I have 5n square plus 4n. I'll have to expand this. 4n square plus 9 plus 12n, and quadratic n square minus 8n minus 9 equal to 0. Factorize 1 and 9, but the sum is minus 8. So minus 9 here. So product is minus 9, the sum is minus 8. So n minus 9 into n plus 1 equal to 0, which means n is 9 or n is minus 1. I think you got the opposite.
Yeah.
I think you made a mistake in the factors. So instead of minus 9 and 1, you wrote 9 and
Yeah.
minus 1. Yeah. So the sum is negative 8.
Mhm.
So 9 has to be minus 9.
Yeah.
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 Also, there's a condition given. N is less than 6. Let's use that. So if n is less than 6, it also means that n is equal to minus 1. It can't be 9 due to this constraint. And since n is minus 1, I'll directly put n equal to minus 1 in this. So I get 2n twice into 2n. Yeah.
Yeah.
So minus 2 into 2 is minus 4, right? And y
Yeah.
is 2. So this is minus 2 whole square becomes 36. I'm
Yeah.
using the first equation. I mean this one, first one.
Mhm.
So once again, how are we solving this? We realize that the expression asked is in terms of some numbers, which means n should be known to solve this. So we do
Yeah.
not simplify this first up, but we use the other two equations. We know that both of these symbols look the same in the same order. So equate.
Yeah.
Yeah. So well tried. I think you just went wrong in that factorization.
Yeah.
Got it?
Okay. Yeah.
Yeah. And also we use this.
Mhm.
So whenever you have two answers in your quadratic, see if in the
Yeah.
question stem anywhere there's a constraint on the variable. It might
Yeah.
help you boil down to one of these values. So
Yeah.
this is all about functions.